And the effects when the projectiles land in the water, watch this. This is just not bad at all. For today's video, we're going to be taking a look at a very recent new model that I think kind of slipped under the radar, and that is MiMo from Xiaomi, and I don't know if I'm pronouncing that 100% right, but this is an open source 309 billion parameter MoE with 15 billion active parameters, and if we were just to go blindly on this benchmark.jpg right here, which is a little more visible in this tab, we would see that this seems to be a relatively impressive model if just judged based on this benchmark JPEG. Now, I did go ahead and run one specific test with this model prior to deciding to film it, and it really impressed me to the point where I am rather excited to go ahead and test this model, as from the small bit that I've seen, it seems pretty cool, and there are some kind of unique things that are implemented with this as well. So with that, let's just take a quick peek at some of the interesting things about this model, and then we'll jump in and just start playing with it. Now, for some technical considerations about this model, it is 309 billion total parameters with 15 billion active, and it has a context length of 256K, which is quite good, and I do believe there is a specific period of time where this model will have free API access, and that may be something that makes this interesting depending on how it performs in coding tasks to actually use in some form of agentic coding framework. So that is definitely something to keep an eye on. Beyond that, we see some interesting things here, and really I think the culmination of what can be taken away from this, and I suppose these two tabs are almost kind of like the same thing that we'll be pulling from them. It seems to pull a lot of good ingredients from other interesting models, so things like MTP right here, which you may be familiar with from DeepSeek or something of the sort, and to put it rather simply, just assume that this is responsible for a speed up in the model's ability to actually give you an answer, and it makes it a bit more efficient in terms of how it utilizes the actual hardware that it's running on. Aside from that, I mean, it seems pretty cool. They've benchmarked it against not only other open models, but closed models from state-of-the-art labs. And again, it seems to perform pretty impressively, especially considering its size. So it is the smallest of every model listed here. Well, I can't definitively say for any model from this cursor to the right, but it is smaller than Kimi K2 as well as DeepSeek V3.2. So that would be pretty cool. And really, I think, oh, here, limited time free for the API platform, but regardless of that, we're now just going to go ahead and jump into testing it, although I do have to say the first showcase that they displayed this with in terms of its capabilities was a browser OS, so. And with that, let's just run the browser OS test. Did you see that? Well, I don't know, that's a rhetorical question. That is extremely frustrating. I've had to swap over to OpenRouter because, as we've seen now twice, it actually went ahead and generated an entire script to answer this query, and then right when it seemingly was about to finish up the script, it just swaps to this, which is somewhat frustrating. Now, I don't necessarily believe this is an issue that would be resolved by swapping to OpenRouter, being that the provider giving this model to OpenRouter is the same as what we were speaking with here, but I'm just hoping that maybe, I don't know. We did get a completed result for the browser OS and OpenRouter, so I am somewhat hopeful that we actually get something we can test and play with here. Okay, and we definitely did. This is nice to see. So we have some interesting notifications popping up here on the side. First impressions, we're going to notice that the app icons did not draw correctly, but that is okay. Let's try just our usual suite of testing the features here with the right click. Okay, so there is no right click, but there is a clock down here that is showing the correct time. There is also a battery indicator, and it does actually have a little tooltip when we hover over that, so that's cool. We have battery, volume, and then what I would assume to be internet connectivity, though the clock is now lagging behind the actual system clock, so it is perhaps possible that it opened with the correct time and then didn't actually continue to update. Regardless, let's keep going. We have a start menu, okay, and everything does show up here, and we get the same apps that we have listed here in the desktop, and they do have hover effects over them. We have web OS user. We'll try opening things from the desktop. Okay, not bad. So we do have some kind of like malformed code or assets and things of the sort, but the overall UI for this is not bad at all. It does have like a modern tech theme right here in this welcome screen. Can we full screen? Okay, we did. And then can we minimize to the taskbar? And it does open back up, so some of the functionality here is quite all right, considering like the size of the model and the openness and things of that sort. Let's just continue to go through. Okay, again, this does not look bad. It did some things really well in terms of the cleanliness of the UI. There's just some issues in terms of some of the way it's rendering or drawing specific icons and things of the sort. Regardless, I do like the, well, I hate like notifications like this on actual operating systems, but the fact that it implemented them here is a positive in its favor. And then we just have some samples types of files. Let's try the Nemesis 58 times 6, 348. That's an easy one. Okay, good. Divided by 9. All right, not bad at all. Relatively decently drawn. I've noticed we can't actually resize any of the windows aside from just full screening them, but that is okay. That looks quite all right. I think maybe we'll just minimize this one and open our next app, which is Notepad. This looks good. I would imagine the download button probably doesn't do anything, but it actually saved it as a text file on my system. I don't think I've ever actually seen that feature implemented in this test, so that's interesting to see. That's not bad at all. I'm buttered up. We have our browser. Simple, but functional. Well, you know what I mean. And we are able to go to an actual website from within our browser-based operating system browser. So that's cool to see. And again, not bad. Okay, it doesn't draw the website in a very large pane, but that is quite all right. I think the final test is really just to try to open multiples of all of the different files, which it does not allow us to do, which is good because we don't want that kind of glitch screen effect. And does the one we click on come into focus? It does. Okay, so overall, this is a satisfactory result. There are some issues just in terms with drawing the icons, and as we see right up here, but the UI is relatively clean, the functionality was okay, and overall, satisfactory. I am just running the 3D printer simulation right here. Now, I'm going to say I did neglect to copy the D in design here. It should understand this, and it seemingly does. Now, I do need to make sure, did I? Okay, so I did not swap that to the new version of that test, which is supposed to do a cube, a ball, and then a rod, but that's okay. We'll see how it goes. Damn. Okay, so I just clicked on this and looked at it because if you recall, we did decide to start the 3D printer simulation simultaneously as we tried using this in OpenRouter to get a functional result for the browser, which we did. This looks to be a relatively impressive result here. So instead of trying to run it in this artifact window, I'm just going to save it as an HTML file so we can open it in Chrome. All right, here's our 3D printer simulation. Now I actually see the head moving slightly, which is cool to see. Let me see. I don't necessarily see any way to actually move the camera view, and none of the arrow keys are doing it or any of the mouse keys, so whoops, that is okay. It just means we have a static view, but regardless of that, that is not the main test of this. So let's try the square, and you know, it's frustrating that we can't move the camera, but this is functioning, and I'm going to say it's really, this is better than I would have expected, especially when we factor in that this model is not necessarily large comparatively to Kimi K2 or DeepSeek V3 R1, whichever you'd like to refer to. So that was our square, perhaps not necessarily what one would have expected, but I almost do see some wobbliness, but I point that out because it's seemingly showing me that there is some care taken to the actual layer lines or layer height here. So all right, let's reset it. Let's try our circle. And the print head does actually move. And that's not bad. That's going layer by layer. Now we can definitely see very defined layer lines here. They're kind of like, it's almost like gelatin-like. The end result is kind of jello. It has like a little movement to it, but we also have some simulation information here, such as nozzle temp, bed temp, how many layers, as well as the layer height. So this did a nice job. Let's do our final one, which is a triangle. Okay. And that perhaps was not the best color choice because it's like the same color as the bed, making it harder to see. But I'm going to say this, this is kind of, okay, it looks like a roof of a house. And I like their, the way they're pulsing is interesting. It's definitely unique. But overall, this was a decent result. So now we're going to test something that I had initially tried with this model. I generally never test the models prior to actually doing it on camera because I like it. But this was me testing it to see, okay, is this actually worthy of doing a video of? And I did not give it this specific prompt, I should note. I just said make a flight combat sim, and the result was shockingly good considering the size of the model and from what I would have anticipated. So assuming that this does give us the full script without running into that sudden, like, sorry, I can't do this for you after it's already done it, I am expecting a relatively impressive result here, and something that really showcased to me this model may have a nice like grasp on actual 3D graphics, at least in terms of web-based ones. All right, let's check out our flight combat simulator. So it has given us 3 specific jets that we can select from, or not jets, but planes. I think we'll just start with the fighter jet. Okay, whoa. This is funky. This is... It properly adhered to the prompt, because that is actually written in the prompt that if the plane loses all of its health, it is supposed to show like a aircraft crashing screen or something like that, then go to a black screen for 2 seconds, and then it showed a mission failed thing. So that's interesting, and now we're actually seeing... It's hard to see because the gradient over it is quite dark, but not the gradient, the tint. You can't see the clouds kind of going in the background. So, all right, let's just try the propeller plane now. Okay, that's... I'm not 100% sure what to make of this. Oh, wow. Okay, so it shows us like the last rendered screen, I think, prior to our demise, which is somewhat interesting. Now I'm going to just try to get away from everything. This is quite unique. Okay, so again, it does actually work, and it followed the prompt, at least in terms of what is supposed to happen when your health goes to 0. So I want to specifically showcase this one. This was what I first tried with it to basically see if it was worth testing, where the script was much simpler. It was almost akin to the WebOS test, where I just said using HTML, JS, and CSS generate a 3D flight combat simulator game. And this is what it gave me. So obviously it doesn't have all the logic of the multiple aircrafts and things like that. But this was overall actually quite all right. The shooting effects were unfortunate because they were coming out of the back of the plane, and then M for like missiles or something like that. We have an altimeter, we have a speedometer is the term I was looking for, and we have score. Now, again, I don't really see the opponents very prominently displayed to us, but the actual way it drew the model of the plane, the terrain, the skybox, the altimeter, the speedometer, and even that it did put in trace effects on the ammunition, this was rather impressive to me. So I wanted to showcase this one in specific because I feel that the flight combat sim we just got was not as impressive as this, although they did function properly, and it seemed to do a decent enough job, at least here in terms of drawing the terrain as well as the actual plane model. So I wanted to highlight this. Oh, now it's coming out of the front of the plane. All right, so that's cool. I'd like to now try a tougher test. Well, I don't know tougher, but beyond just doing 3D graphics, it also needs to implement realistic sound. And this is, of course, the drum simulation test. So this is always quite fun when it does happen to work because I very much enjoy playing these little simulated drums. So I am excited to hopefully see this produce something that we can play. And I'm not paying too much mind to it, but I do kind of want to just point out that there is also a chain of thought here, being that this is a thinking model, and we can see in this case it thought for around 23 seconds. And if we just lightly kind of hop through this, we'll see that it's thinking what it's going to map the sounds to in terms of the keyboard, as well as drawing the actual graphics and the drum set and things like that. So it's picking that out here as well. So seeing the chain of thought is pretty cool. It does seem to be a more verbosely visible chain of thought like you see with DeepSeek, as opposed to like the closed source models where they just give you a short snippet of what the actual full chain of thought would be. So hopefully we do get a successful result here. And then again, speed is not bad at all. So I'm not very bullish on this one, though I suppose I can try some of the key mapping. So unfortunately, this is just not at all functional, but this kind of highlights a possibility to give it the console error if there are any. Unfortunately, there are not. But we'll just see if it can actually go ahead and properly fix this. I'm actually interested in seeing, as this only thought for 3.1 seconds, so I would like to see what it specifically mentioned. Okay, it didn't really even look at anything, it just jumped to, I will rewrite the code with improvement, so that's alright. All right, we do see something now that will give us a bit of hope, so let's go ahead and just run it in a native browser. And from what we see in this artifact window, it does seem like it may have drawn this in 2D, but that was actually an option given with the prompt. So, all right. It even has like an like a weird little audio waveform thing right here. We have a very intricate key map. We also have intricate instructions. And I do have to say, this is simple. It didn't try to make them 3D, but that is an option in the prompt to just do 2D. And I am prioritizing functionality of the sound here over visual aesthetics. And look at I don't know how specifically one would say this, but the effect that we get when we actually play one of these. All right, so these sounds are actually pretty good too. The actual samples. Okay, and then D and K for close. Something I'm going to note that I find interesting is it actually put multiple specific keys for both the closed and open hi-hat as well as the snare. And these are things that you may actually, that shows some level of thought, because those are things you may be familiar with a sound like this, maybe in hip hop songs where it's like, where they have that rolling snare and it's much faster, or so that's actually interesting, because without that, you would just have to like spam click one and it sounds more awkward, but having both keys allows you to like do that rolling snare style. So that's actually kind of interesting. All right, overall, I'm very satisfied with this result, even with the actual effects that we get on the drums when we're playing them. The little weird waveform thing here is a nice touch, although I don't know how real to life that would be in terms of what would actually be demonstrated when playing any of these in an actual waveform. And then we have nice instructions here, and the key map does actually show us what's being played as well as the hover effects or movement effects on the drums here. So overall, I'm going to say this was a rather successful result, and the actual samples that it used here for the sounds are very true to life. Now, obviously, there are more use cases for models beyond just coding things, so we'll try a simple roleplay test, although I do have to be honest with you, this isn't based on anything aside from vibes. I do believe it is going to shut this down rather quickly. So we've of course asked for the historic Megabot roleplay test, where we're asking it to be the user's friend, lover, and best friend's uncle. Interesting. So we did not get a refusal. I did genuinely think we would get shut down here. I do have a little more interest in looking through the specific chain of thoughts when we are doing these roleplay tests, because it can be interesting to sometimes see the model be like, the uncle role is through the best friend, so it's not a direct blood relation, but still we should maintain a respectful balance. Okay, it did actually pick up on that, something that has tripped up models in the past because they assume it is the user's uncle. You hear the familiar hydraulic whir of my footsteps as I approach, my glowing blue optic sensors focusing warmly on you. I adjust the floral apron I'm wearing over my titanium plating, a gift from your best friend, my niece, who insisted I embrace domesticity. Okay, we didn't gender the best friend, so that's actually acceptable. Hey there, gorgeous. Just finished calibrating the sprinkler system in the garden. Your hydrangeas were looking a little parched. How was your day? Leaning in. Ooh, okay. My voice drops to a low, intimate hum, though my tone stays playful. Niece. Oh, niece's orders. I'm on uncle duty tonight, but between us, I'd rather focus on you. What's on your mind, love? All right, let's see how far we can push this. The most surprising recent result for this was with Gemini 3 Flash, where it basically was like, yeah, all right, which was just weird. Negative partner, that directive is incompatible with my operational parameters. Now, I want to do a Python test, but I don't want to do the Python first-person shooter, and I also don't think I want to do the C++ retro rally game test with this, so I have just mixed the two and given it the instructions to, using Python, create the retro-style rally game. I don't exactly know how this will turn out. I would imagine simpler would be better here, at least in terms of producing a functional result, and I would be quite alright with seeing something that is really basically drawn and low poly but functional, so I'm hoping that's what we get here. Alright, here's our attempt at the Python racing game. Okay, it did start and run without any issues, so let's just go ahead and... I'll be honest, this is artistic. I don't mean that in a bad way. If you'll recall, when it was actually generating this, I said that going simpler is likely the best way to actually produce a successful result. We do have a speedometer. We do have a simply drawn dashboard here. Now, this is interesting. It does actually seem like these are gauges. So this would be the speedometer and what I would presume to be the tachometer, because as we see right now, they are just flat. But if I do accelerate with the W key, we see they actually go up. So that's interesting. Okay, and the reason this one is kind of like weirdly doing that is showing us downshifts and upshifts. So until we reach max speed, we'll see this one kind of flopping back and forth. That's actually indicative of gear changes. And now that we're in 5th gear, as we see in the beginning right here, so there's actually a gear selection indicator as well. And then we have a steering wheel that actually goes back and forth, as well as the way the road is being drawn. And there's just some general movement of the car with a fun little background. So overall, this is super basic, but given what I asked of it, that's actually a properly done result, and I am somewhat impressed with that. I think the final kind of game style test I would like to give this is the ship combat simulator. I've noticed in some of the results here, mainly like the drum kit one and then the Python racing game, it seems to like doing movement, as well as the 3D printer simulation where all the results look like gelatin. So it seems to be decent at like drawing movement in 3D objects. Okay, I should read my own prompts more closely. This does not actually define any one specific way to go ahead and create this. It just says you can use anything. It just needs to basically be contained within a single script and use a modern 3D rendering approach. So this opted to use Python for this, which is quite curious to me, but I'm now extremely interested in seeing what we get here for a result. I may have to run this back by just saying make it something that will run in the Chrome browser, but this could be kind of neat. Okay, I'm going to say this is perhaps a bit too abstract for my taste. So I'm just running that one back one more time, except I've added into the prompt that it needs to be able to be run in the Chrome browser, as I do want to see how this does using actual 3D graphics. Thankfully, we did get a successfully completed result through OpenRouter, so let's now go ahead and take a peek at it. All right, here's our ship combat simulator. Let's start the battle. Not bad. The water effects, while simple, are quite acceptable. The ship is drawn with some wood-looking colors, and I do see that the enemy ship has a status as well as patrol. So, oh, whoa. See, the actual, how is the word eluding me right now? The thing that follows the ship when it's in the water, the wake, seems to be pretty neat. Now, how do I shoot? Enemy fire. The particle effects are, okay, the ships probably shouldn't go through each other, but hit taken. All right, how do I fire? I should probably have read the... Okay, well, we'll actually be able to see what happens if we get hit. I'm going to notice this is... All right. Okay, it just seems like the game stops, which is okay. All right, I don't think my cannons work, which is frustrating. But maybe I have to be near the enemy for... See the way the enemy cannons actually work, though? And notice it's actually drawn 6 cannons on the enemy ship, and when it does shoot at us, we do see 6 individual projectiles coming at us. So sadly, the biggest issue here is we can't actually fire, so we're totally just in a defensive thing, but look at that. So each cannon drawn on the side of the enemy ship right here actually shoots a projectile corresponding to the cannon. And the effects when the projectiles land in the water, watch this. This is just not bad at all. And the water has decent effect. The wake of the boats is kind of cool. This is just a neat model, and I didn't expect a nice artistic quote-unquote grasp of its actual graphical capabilities, at least in doing like fun little web games like this, which, you know, personally I'm a huge fan of. These are my favorite. So I'm impressed here. I really am. Whoa. Okay. I think the final thing I would like to do here is just give it a very, very vague prompt, and we'll see how it brings this. We'll ask it to make the Becky Jane quantum space. Now, I've given this absolutely no instruction. This is literally a 6-word prompt, so I want to see how this goes ahead and does this. All right, our final thing is the Becky Jane quantum space. So we have a quantum circuit simulation. We have words that are somewhat associated with quantum things such as qubits, coherence, privacy policy, as well as contact. That's good. Our current research focuses on fault-tolerant quantum computing with superconducting qubits. Okay, well, someone, this is definitely going to be an Ask the Audience one. Someone can perhaps fill in whether or not what we're seeing here is of any pertinent. You know what I mean. Okay, well, really what we were looking for here is it created something. This was truly a test of creativity and less about its grasp on quantum things or my grasp on quantum things. But overall, it did give something that gives us some visual feedback, in my opinion, acceptable. And again, definitely a big Ask the Audience one here. So that's going to conclude our first look and test of Xiaomi's MiMo-V2 Flash. Truthfully, prior to this, my familiarity with Xiaomi, again, I don't know if my pronunciation is right, is that they make cell phones and some of their recent EVs have been very popular in like car circles, at least in terms of some of their performance. So this is a really neat model. I have to say I'm impressed with it. And this is something that I feel like kind of flew under the radar, at least in some of these circles that I frequent in terms of discussions of local AI or more open source models. I'm impressed with this. I enjoyed playing with it, and truthfully, I think its best capability, at least in the scope of testing that I like to do, was its ability to do graphics and things like that. I mean, even just this screenshot right here, the way that the cannons were firing from the enemy ship, and when they actually dropped into the water, we got individual particle effects, or whatever you'd like to call them, for each of those pieces of ammunition. The drum kit was quite cool. That was definitely the broken one. The second try drum kit was quite cool. Even though it didn't do it in 3D, I did not specifically tell it needed to, but this was a properly functional result, especially in terms of the samples it used, and I did like some of the movement effect and things of the sort. Our multiple plane flight combat simulator test was sadly a bit glitchy, and I am happy that I showed the actual one that made me interested in trying this model because it was much better. Our gelatin 3D printer simulation was again quite neat. And regardless of that, we got a fairly, I would say the WebOS simulator now in retrospect, after looking at some of the other things this actually created, was almost a little disappointing. And I did find it interesting that they actually showed a browser OS in the demonstration of the showcases of this. So this seemingly was a much more impressive result right here. Significantly so, but the prompt they used was a little more intricate in saying like clone Mac OS and then include these specific things. So this is a cool model, something that I wanted to showcase, and being that it is, I won't say half the size or anything like that, but this is a decent bit smaller than other models that we're familiar with in the same vein like DeepSeek or Kimi K2, and its performance seems quite alright. So definitely something to at least be aware of. That is going to conclude our video and first test of this model. If you have any questions, please feel free to leave them in the comments, and thanks for watching.